Hello everyone, myself Sneha Murthian, studying in Sri Venkateshwara College of Engineering from ISA branch. Today we are going to discuss a topic called shared memory and client server properties. First here is the shared memory and the client server properties. Unix, a powerful operating system, offers the developers powerful tools for inter-process communication, including the shared memory and the client-server architecture. This presentation explores the benefits and the applications of these key concepts in Unix programming. This is all about the shared memory and the client-server properties. Here we can see the intra-process communication including shared memory and the client-server architecture and the applications of these key concepts in the Unix program. And the next is introduction to the shared memory. First in that we have shared data. Shared memory allows the multiple processes to access the same block of the memory, enabling the efficient data sharing. And the next is performance. Compared to other IPC mechanisms, the shared memory provides the faster data exchange between the processes. And the last one is synchronization. The shared memory requires the careful synchronization, raise conditions, and ensures the data integrity. Here we can see the picture of the memory and the processor, how the memory is connected to the four processor in the right side and the left side. This is the architecture of the shared memory which we can see. This is all about the benefit of the shared memory. And the next is shared memory segments. Here we can see how many segments are there in a shared memory. Here we can see the three segments. First is allocation, attachment and detachment. Allocation refers to shared memory segments are allocated using the system calls like SS shared memory get, that is SHM get, which is represented in a open and closed brackets. And the next is attachment. Processes attached to shared memory segment using SHMAT to access the shared data. And the next is detachment. We can process no longer needs to the memory, it detaches using SHMDT. And the next is shared memory operations. In this we can see the four types of shared memory operations. First one is creation. Creation refers to shared memory segments are created using the system calls like SHM get. Here the creation is created by using a system calls like SHM get. Here the operation SHM get is used. And the next is attachment. The processes attached to shared memory segments using SHMAT to access the data. The attachment is attached to the shared memory using SHMAT to access all the data. Without that, we can't do any attachments. And the next is synchronization. Semaphores and the mutexes are used to synchronize access to the shared memory. This is about the synchronization. And the last one is deletion. Shared memory segments are removed using SHMCTL when no longer needed. Here we can see the picture about the shared memory. And first, here is the progress one, and here is the progress two, in which it contains the virtual memory. It is shared to the physical memory through this bond. So this is a diagrammatic representation of shared memory operations, which contains four four operations, that is creations, attachment, synchronization, and deletion. Next is client server architecture. First is clients. Clients initiate the request and send them to the server, which process the request and send the back responses. Here how the client works means which process the request and send the back responses. The responses which are given by the clients, we have to respond those. This is the main thing we have to do when the clients came. And the next is the servers. Servers listen for the client request, perform the necessary processing and returns the results to the clients. Servers should do whatever the client will ask from the request that they have to do through the servers. And the next is communication. Clients and the servers communicate using well-defined protocols such as HTTP and FTP or custom protocols. These are the communication protocols which is used by the clients and the server, that is of HTTP and FTP protocols. These are very useful in communicating between the clients and the server. This is all about the client-server architecture. Next is inter-process communications, that is of IPC. In that, first is pipes, unidirectional data flow between the processes, that is called pipe, and is message queues, that is asynchronous communication using wide messages. This is a message queues. And the next is shared memory, direct memory access between the processes. And the next is the socket, network-based communication between the processes. A guide to interprocessor communication in Linux. This is a picture. Learn how the processes synchronize with each other in the line by Matic cabling. This is a picture which represents the interprocess communication. Next is the sockets and the message queues. First is socket communication. Sockets enables the network-based communication between the clients and the server. It enables the communication between the clients and the server, and that is whatever the clients and servers will talk, it will be stored in the socket communication. So it links between mainly the clients and the server. Next is the message queues. Message queues allow asynchronous, loosely coupled communication between the processes. It will allow the asynchronous coupled communication between the processes. Next is flexibility. Both the sockets and the messages queue are in IPC options with the different traits of the sockets and the queues. This is the diagram which they given to the sockets and the message queues. These are the three things that we learn about the socket messages and the queues. That is socket communication, message queues, and flexibility. Next is shared memory in client-server application. In that, the first one is performance optimization. Shared memory can significantly improve performance in the client-server applications by reducing the data copying. Next is caching and buffering. Shared memory is often used for the caching frequently accessed data or buffering communication between the clients and the server. And the next is synchronization changes. Carefully synchronization is required to change the consistency and the condition which is stored in the shared memory. These are the three things. That first one is performance optimization, next one is caching and buffering, and the last one is synchronization challenges. This is all about the shared memory in the client server applications. The last one is the conclusion and the best practices. First is leverage shared memory. It utilizes the shared memory to improve the performance and efficiency in client-server applications. And the next is implement the robust synchronization. It ensures the data integrity by employing appropriate synchronization mechanism like semaphores and mutexes. Next is consider the hybrid approaches. Combine the shared memory with the other IPC technology as sockets or the message queues for the optimal research. This is the conclusion and the best practices which we do in the Unix program. Thank you so much for watching this video.